Namaste to all my dear students. How are you? Again, you are giving very interesting video about the phosphor and what to see, contrast and compare the properties of HCl, HBr and HI. That is very important for knowledge as well as examination viewpoint. Generally asked in examination. So what's next heading is what to see, contrast and compare the properties of hydrochloric acid, hydrogen bromic acid, hydroiodic acid. Yes. So that is very important. So in this case, we have to mention all the similar as well as dissimilar properties. Yes. So make a table at first. So what we see, HCl acid, what is the HBr acid, next one is what we see, hydrogen iodic acid. Yes. So first one is state and color. So what is the colorless gas? It is also colorless gas. It is also colorless gas. Yes. Second one is what to say, odor, a smell. Pungent means irritating. Pungent, that is also pungent, irritating you can say. Second, it is also pungent. It has also pungent smell. Third one is solubility in water. Highly soluble in water. It is also highly soluble in water. It is also highly soluble in water. Yes, these are the similar character we can say. Fourth one is what to see, reaction with base. Why? Because they are the acids. So what to see, sodium hydroxide when treated with dilute hydrochloric acid, you know that is also aqueous solution dilute. So what we have, sodium chloride plus water. You know, when any acid is treated with base, what we get, salt and water, that is salt. Yes. Also react with base plus dilute HBr, what we get, sodium bromide plus what we say, water, that is sodium bromide, that is also aqueous solution. Yes. Next one is sodium hydroxide aqueous solution made in water is known as aqueous. So when that is treated with the hydrogen iodide, so what to get, sodium iodide plus water, that is sodium iodide. Yes. Next one is what is the stability. So what is the HCl is what is the stability is high, low, least. How can you say? So what is the HCl? You know electronegativity of hydrogen is 2.1, chlorine is what is the 3.0. So what the difference over here? What is the 0, 1 and what's the 3, 2 or 1.1 difference over here? That is the electronegativity value. So difference is what you see 1.3 1 what is the 10. So what you get 0 9 and what is the let I will describe it, explain this one. High stability, there is low stability, least stability. Yes. Next one is reaction with ammonia. You know the formula? NH3 plus conc HCl. What you get? Ammonium chloride, that is ammonium chloride, white fumes like cloud we can say. Yes. So when that is what you see next one, NH3 plus HBr, that is base, that is acid. So what we have? Ammonium, that is ammonium, right? White, that is also white fumes. Next one is NH3 plus hydrogen iodide. So what we have? Ammonium iodide, that is also white fumes. These all are similar, I can think. Next one is reducing properties. Reducing properties. So what is the manganese dioxide? You know, oxidizing agent. That is what is a conc HCl. So what you get? MeCl2 H2O plus Cl2. Yes, like this. What you get? So what you see? 7 number. So what you see? Manganese dioxide. That is manganese dioxide. What is the conc hydrogen bromide? So what do we have? H2O plus Br2. That is manganese. What is it? Bromide. So what you see? MnO plus what you see? Hydrogen iodide. So what we get? I2 plus H2O. That is manganese iodide. Yes. So what you see? That is reducing properties is low, high, maximum. What is the least? This case is high. In this case is what we say, maximum. So when you balance these chemical equations, what we have? When you balance, so after balancing, what we have? MnO2, 4HCl, 4HCl, MnCl, 2H2O. Yes, so what do you see? 4 HBr, 2H2O, like this, HI, 4 HI, H2O plus what you see, iodine. So what you get? 4 HCl, what is H2O? 2H2O. Yes. So that is reducing. When we talk about the reducing agent of the HCl, that is the least, what you see, very least. That is high, that is what you see, maximum. Next one is next point is what you see, 8, reaction with Cl2. Tell me what the reaction over the HCl and Cl2. Tell me any idea about? So in this case, no reaction. Why? Both are oxidizing agent. That is also oxidant. That is also oxidants. No reaction over here. But over here, so what we have? Yes. So what we had? HBr plus. So what you know? Mild reducing agent, that is oxidant. That is reductant. Reducing agent, that is oxidants. So what we have? HCl plus Br2. So what we have? So HCl, 2Cl over here. Yes, Br2, 2HBr. Yes. Likewise, when you talk about the HI plus Cl2, what is the oxidant? That is a strong reductant. So what we have? HCl plus I2. So 2Cl2, yes, 2I2, yes. Next one is reaction with concentrated sulfuric acid. So what we have? So what you see? HCl plus conc sulfuric acid. Tell me any reaction. What happens when HCl is treated with H2SO4? So in this case also no reaction. Why? Because both are oxidant. It is also oxidant. So no reaction. So in this case also there is no reaction. Yes. So keep in mind. Why there is no reaction? Because both are oxidant. So I have already told you that oxidation reduction chapter is very important. Yes. So what we say 1 8 number, what is 9 number? So HBr, you know, conc sulfuric acid when heated, that is the oxidant, you know, oxidant, that is the reductant. So all chiral to each other. So what do we have? H2O plus SO2 plus Br2. I have already told you in the question. So HBr, when balance this chemical equations, what do we have? In this case 2H2O 2H2O on 2HBr, yes, like this. So what do you see? HI plus sulfuric acid when heated. So what do you see? That is the reductant, you know, that is the oxidant reaction, and what we have? H2O plus sulfur dioxide plus I2. So what's it? 2HI, and what is it? 2H2O. Yes. Why reaction over there? Because reductant and oxidant. So there is reaction, but when we talk about the HCl, in this case, no any reaction. Why? Because both are oxidant. Yes. Next one is number. Reaction with what to say? Silver nitrate solution. That is silver nitrate solution. Yes, what we have? HCl plus, that is all aqueous. It is also aqueous. So there is what we have? AgCl plus what we see? Nitric acid. That is what we see? Silver chloride. And what type of PPT? White precipitate. White precipitate. It is highly soluble in ammonia. Yes. So what do you see? Reaction with what do you see? HBr plus, that is aqueous, silver nitrate solution. It is also aqueous. So what do you see? Reaction, and what to get? HBr plus what do you see? HNO3. So that is pale. Pale PPT. PPT means precipitation. It is slightly soluble in what do you see? Ammonia. Slightly soluble in ammonia solution. Yes. So that is what you see, HI plus aqueous solution, that is also aqueous. What we have? Silver iodide. So what type of PPT? Deep LOPPT. Side product is nitric acid. Yes, it is insoluble in ammonia. Yes, so these are the what you see. Contrast, sometimes ask you examination 5 marks. So you have to write all these 10 questions over here. So sometimes ask you reactivity order. Reactivity order of acid. Reactivity order of what you see? HCl, hydrobromic and hydroiodic acids. Look at over here, reason. So, order is like this, is more than what you see HBr is more than what you see HCl. It is what you see weak, that is strong. Now, question arises, how, why? Yes. Look at the reason why HI is more it shows a more acidic character with respect to HBr and HCl. So, what you know, that is the monovalent bond. Yes, you know the reactive what you say electronegativity value of hydrogen is 2.1. Always keep in mind, and iodine is 2.4. So, what the difference over here? 0.3. Yes, difference over here. When you talk about what's HBr, 2.1 and what's it 2.8. So, what we have? 0.7 difference over here. When you talk about the HCl, what you get? 2.1, 3.0. So, what you see? 0.1, 0.9. Yes, and 2, what you see? 0. So, what the over difference over here? 0.9, 0.7, 0.3. It means it has hydrogen iodide has weaker bond. It has a stronger bond. That is the electronegativity value. So, what do you see? In this case, difference is very low. So, it can dissociate easily. When comparison to what HBr, it has what you see more stronger bond. So, it dissociate, yes, no doubt. But in comparison to HI, what you see slowly. But when you talk about the HCl, this also what you dissociate in what in water, you know, and but very poorly, slowly. Why? Because the bond is very strong. To break the bond, we need more solvation energy. In this case, we need slightly less. In this case, what do we need? Very low solvation energy. So, it gives easily, yes, it gives easily H plus ions in water. So, stronger acid. Yes, in this case, what we see? A stronger bond difference. So, what you see? It gives H plus ion with difficulty. It means it is weaker acid. Yes. So, this question generally asked in examination. Yes. Next one is test for halides. We are clear why HCl is weaker acid, HI is stronger acid. That is the stronger, that is the weaker acid. Yes. Now, test for halides. I have already talked in what is organic chemistry. So, halides means X negative charge, maybe chloride, maybe bromide, maybe iodide. Yes. So, when that is treated with what we say, treated with silver nitrate. So, what you see, when silver nitrate aqueous solution is treated with chloride. So, what we have, AgCl plus what you see, nitrates. What type of PPT we get over here? White silver chloride. Likewise, when we talk that is aqueous solution, when that is treated with bromide, that is bromide. So, what we have, silver bromide plus what you see, nitrate, that is nitrate ion, that is the pale yellow, pale yellow PPT. Yes. Likewise, what is this silver nitrate aqueous solution that is treated with iodide, that is chloride. So, what we have, silver plus that is silver iodide, that is what type of PPT, deep yellow. So, always keep in mind, if halide is treated with silver nitrate solution, that is the suitable reagent for what we say halides. So, if gives white PPT, may contains chloride. If gives pale yellow PPT, may contains bromide. If reacts with iodide, what we get, deep blue, what we say PPT, what we have, iodide. So, that is about the test 4. So, but generally chloride ion is asked in examination. So, what do you say? So, when AgCl white PPT further treated with what you see, excess of ammonium hydroxide solutions. So, what we have, AgNH3 plus what we see, AgNH3 silver iodide (2NH4) what we see, chloride ion, that is what you see, diamine. How many amine over here? 2 amine, diamine silver, that is a complex compound, silver first means oxidation number is, that is soluble in water, that is complex compound, plus side product is what you see, water, 2H2O. Now, this diamine silver chloride, AgNH3 chloride, when treated with nitric acid, what we have, AgCl plus ammonium nitrate. So, what you see, white PPT repaired. It shows 100%, sorry, 99% confirmed test for chloride. Yes, that is generally asked in examination. So, yes, after balancing what we have, 2HNO3, ammonium nitrate, 2 ammonium nitrate. Yes, yes, so that is about important question of what do you say lab preparation of HBr. We are familiar with lab preparation of HBr, HCl and HI, and also we have clear about the contrast compare properties of what you see HCl, HBr, HI. If you know all this, so you have never problem to write any question related to this what you say halogenaceous. So thank you for watching this video, interesting video. Have a nice day. Be bona fide in chemistry like silicon sir. Rest is okay.